Hello and welcome back to Educator.com and welcome back to AP Calculus. So today we're going to talk about the problem of finding the area under a curve from one point to another point. Let's jump right on in. Okay, so I want to find, so let's see. I want to find the area under the curve f of x equals x squared from, let's say, x equals 1 to x equals 5. Okay, so that's my task. So here's what I want to do. So I'm going to draw my x squared curve, something like that. And I'll say that this is my 1, and I'll say that maybe 5 is over here. Okay, so I want to find the area under the curve from the x-axis up to the curve. So that's what I'm looking for. How can I do that? Well, what I'm basically going to do is I'm going to approximate it first with rectangles because I have a formula for finding the area of a rectangle. It's just base times the height. So I'm going to draw a bunch of rectangles approximating it that way. So let's start and see what happens. So the first thing I need to do is to choose how many rectangles I need to start with. In this case, I'm going to just start by approximating it with 4 rectangles. So I'm going to break up my domain into 4 sections. So this is my halfway mark, that's my halfway mark, that's my halfway mark. So I have boom 1, 2, 3, and I have 4. So now I'm going to draw my rectangles. So let's say I start with an approximation using 4 rectangles. Now the number 4 is arbitrary. I could have used 3, I could have used 7, I could have used 10, I could have used 114. It just, 4 gives us a chance to actually sort of, it's not too many, and it allows us to see what's going on theoretically without burdening us with too much, drawing. That's all. Okay, so now here are the rectangles that I'm going to draw. It's going to be 1 rectangle, 2 rectangles, so this is my first one. I want that area. This is my second, this is my third, and this is my fourth. I'm going to find the areas by multiplying the base times the height, base times the height, base times the height, base times the height. That's going to give me an approximation to the area under the curve. Now these parts right here, obviously they're not going to be included, so it's going to be an underestimate. We'll deal with that in just a second. So my first area, area 1, that's just going to be 1, right? This is from 1 to 5. So this distance is 4. Well, if I break it up into 4 rectangles, each distance, each base length of a rectangle is 1. So the first area is 1 times the f of 1, right? Because this height right here, let me do it in red. This height right here, it's just f of whatever 1 is. It's up to the graph. This is my graph. F, which is equal to x squared. So it's just 1. So equals 1 times 1 equals 1. Good. Now my area 2. Well, my area 2 equals 1, which is the base, times f of 2. This is 3, this is 4, this is 5. So this is going to equal 1 times the f of 2. Well, the f of 2 is 4. So it's going to be 1 times 4, which is 4. I take my third area. My third area is going to be this one right here. It's going to be 1 times the f of 3, because the height of the rectangle is f of 3. So 1 times f of 3, which is equal to 1 times 9, which is equal to 9. And then my fourth area, which is going to be 1, which is the base of the rectangle. F of 4 is going to be the, excuse me, the height of the rectangle. So 1 times f of 4, which is equal to 1 times 16, which is 16. I add these together. To get an area, L equals 30. And I'll put a little 4 here. This symbolism that I'm using, the area L, 4 stands for the number of rectangles that I actually chose, the number of divisions that I made to the domain. L stands for left endpoint. I chose left endpoints, the rectangle, the left endpoint, to go up to my graph. Left endpoint for this rectangle, left endpoint for this rectangle, left endpoint for that rectangle. So that's what this symbolism means. So my first approximation, using left endpoints as my height, the f of the left endpoint to go up to make the height of the rectangle, that gives me an approximation of 30. Now clearly this is an underestimate, not a problem. So let's go over here and let me redraw it real quickly. So I have got this, and I had this one, I had this one, I had this one, and I had this one. This is 1, 2, 3, 4, 5. So this area was area 1, this was area 2, this was area 3, and this was area 4. Okay, so notice that this AL4 equals 30 is an underestimate. Is an underestimate because the approximating rectangles are below the graph. The approximating rectangles are below the graph. Okay, now, so I arbitrarily chose 4 rectangles. The left endpoints of each rectangle they're the ones that correspond to x equals 1, x equals 2, x equals 3, and x equals 4. Left, 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 left. Of the points that I can choose in my domain, I chose left endpoint starting from the left. The heights of the rectangles corresponded to f of 1, f of 2, f of 3, f of 4. All right? So it was the distance from 1 to 2 times the height at the left endpoint. This base times that, this base times that, this base times this base times that. Okay. Let's do the same thing, same graph, f equals x squared, same number of rectangles, 4, but let's choose 4 different rectangles, but all over that same domain. Okay, so let's do this again. Let's go back to blue. So let's do this again, but choose 4 let's choose a different 4 rectangles. A different 4 rectangles. But still 4 rectangles. Great. So now I've got my drawing again. I've got my x squared graph. I have 1. I have 5. Midpoint, midpoint, midpoint. So now I've got 1, 2, 3, 4. This time, I'm going to choose these rectangles. Sorry. Okay. Now I have area 1, area 2, area 3, and area 4. Now, my area 1 is equal to, well, the base of the rectangle is still just 1. We'll go ahead and do this in red. It's still 1. So it's 1 times, but this time I'm going to take, notice the height of the rectangle is this height right here. That's f of 2. So it's going to be 1 times 4 equals 4. Area 2 is 1 times, this time it's f of 3. That's my rectangle right there, right? That's the height of my rectangle. So it's going to be 1 times f of 3, which is going to be 1 times 9, which is 9. My third area is going to be 1 times f of 4, which is 1 times 16 is 16. And my fourth rectangle is going to be, the height of the rectangle is going to be 1 times f of 5, which is going to be 1 times 25, which is 25. So notice this time I've taken right endpoints. 4 for each rectangle. From the right endpoint, I went up to the graph, and from there I drew my rectangle to the next x value, drew my rectangle to the next x value. Now I add these together. These together to get an area using right endpoints, 4 rectangles, I end up with 54. That's it. Okay, draw a quick representation of it again. So this time I've got this, and I've got that. 1, 2, 3, 4, 5. This time my rectangles are 1, 2, 3, 4. Now it's this area, this area, this area, and this area. Okay. A right 4 is an overestimate. You can see that it actually goes, here is the graph. The rectangles go above the graph. So, is an overestimate. So that's clear to see. So again, we have 4 rectangles. The right endpoints, they correspond to 5, 4, 3, and 2. I'll write them ordered this way, but I'll write it backwards. So x equals 5, x equals 4, x equals 3, x equals 2, to demonstrate that I actually started from the right working left. And the heights of the rectangles they correspond to, well, f of 5, f of 4, f of 3, and f of 2. Okay, so the true area, back to blue here, clearly the true area is something between the overestimate and the underestimate. It's going to be more than 30 and less than the 54, whatever it is that we got. The true area, which we'll call A, is between these two. In other words, the true area is less than or equal to A right and is greater than or equal to A left, 4 and 4. This one was 30, I believe, and this one was 54. So that much we know. So we know we have an upper limit, and we know we have a lower limit. We know that the area is going to be somewhere in between them. Okay,